Hello friends and welcome to a lecture on Operation Research. This lecture is about using Big M method to solve a linear programming problem, but there's a slight difference here. We'll be using the calculator to solve it. I am Professor Arvind Prasad. Let's get ahead. What we learn in this lecture? When do we use Big M method and how does the calculator speed up the calculations? And why did I make this video? Well, it's obvious. It's a very novel way of solving the Big M method on calculator, which improves the speed of your calculations and reduces the chances of making very silly mistakes so that you lose marks or you do not get the answer. When do we use the Big M method? Well, we use it in linear programming problems as said earlier, and in linear programming problems, if the constraints are of the type equal to or greater than equal to, then we have to resort to this method to solve the problem. It's a slight modification of the simplex W method. We'll look into it, how the modification has been done. And let's take an example to demonstrate this. So what we have is we have to maximize the objective function 3x1 minus x2 subject to the constraints given below. Now watch carefully. In the second constraint, what you have is you have greater than equal to sign. That is x1 plus 3x2 greater than equal to 3. Whereas the first and the third constraint are less than equal to. The additional constraint, of course, is that x1 and x2 both should be non-negative or both are greater than 0, greater than or equal to 0. To solve this, we introduce slack, surplus, and artificial variables in the constraint. So what do? Is we introduce the first slack variable, that is S3, in the first constraint. So we get 2x1 plus x2 plus S3 is equal to 2, where S3 is the slack variable. In a similar fashion, in the second constraint, we introduce a surplus variable S4 and an artificial variable A5. So it now becomes x1 plus 3x2 minus S4 plus S5 plus A5 is equal to 3. And of course, we again introduce a slack variable in the last equation. So as you can see here, we introduce a slack variable when the constraint is less than equal to, and we introduce a surplus variable when the constraint is greater than equal to. And of course, additionally, whenever it is greater than equal to, we introduce an artificial variable. So the objective function now is rewritten as 3x1 minus x2 minus ma5, where m is a very big number. We have to iterate in the simplex W. We have to iterate in such a fashion so that a5 is 0. And when a5 becomes 0 and x1 and x2 are changed, for the final x1 and x2, that is the optimal x1 and x2, and a5 is equal to 0, we get z as the maximum value, or z is the maxima at that point. What is the trick involved here? The trick involved here is that you have to assume a very large value of m. Now, the idea in the previous slide also is that m is a very, very large variable. So unless I do not make a5 equal to 0, unless I do not iterate till a5 is 0, I will never get the maxima. Okay, and as for the calculators, I'll be demonstrating it by using a simulator of Casio FX991 series. And it is better to use this calculator, or at least I'm comfortable with this calculator because it can display and solve fractions. So that's of great help when you're solving these problems. Now, let's see what is the value of m that you have to guess, or rather you have to estimate. The value of x2, as you can see, is not greater than 4, looking at the constraints. And the value of x1, it should be somewhere between 0 and 2. So the estimate of Z is, the maxima of Z would be somewhere too. It's an estimate. Of course, it's not the final answer. So we assume a value of M which should be far more greater than the final maxima value of Z that you are going to get. So we assume a value of M as 100. Now the crucial step here comes in. That is, you have to eliminate A5 from the objective function. Now how this is done? We all know that the second constraint is 3x1 plus 3x2 minus s4 plus a5 is equal to 3. Now we rearrange this equation and multiply m on both the sides. And then afterwards we add it to the objective function. And then of course we go back and take m is equal to 100. And we finally get our objective function where m has been taken as 100 and a5 also has been eliminated out. Now getting ahead, on the top you will find the simplex tableau, the starting simplex tableau. Okay, I'll explain how this simplex tableau has been prepared. What is the logic behind preparing it? So in the leftmost column, you have the variables Z, S3, A5 and A6. And on the first row, you have Z, X1, X2, S3, S4, A5, S6 and RHS. So in the first row, you note down all the variables of the problem. And of course, you leave the last column for the right hand side of the equation. Now, if you come to the equation of the objective function, that is Z, you'll find that the coefficient for Z is 1. The coefficient for x1 is minus 103. The coefficient for x2 is minus 299. S3, of course, is 0. A5 is 0. S6 is 0. But for S4, it is 100. And the RHS is minus 300. If you go to the first constraint, these will be the values of the coefficients. If you go to the second constraint, well, I have noted it down. You can cross-check it. And the third constraint written in the last column. Why have I noted S3, A5 and S6? These are the starting basic variables. Now, what is the idea of basic variables? In any system of linear equations, if the number of variables is greater than the number of equations, then what do? We subtract the number of equations from the number of variables and we get the degrees of freedom. Okay, now degrees of freedom are those variables or those number of variables for which you have to assume a value to start for the solution process, right? So S3, A5 and A6 are nothing but the basic variables or variables for which we have to take a value to start solving the simplex tableau. Here, x1, x2 and s4, they are nothing but the non-basic variables for which a solution, we have to get a solution. Okay, I hope you have got it. Now, x1 is 0, x2 is 0 and s4 is 0. Obviously, s3 is going to be 2. A5 is going to be 3 and S6 is going to be 4. As I said, basic variables are variables for which values have to be assumed. So I have taken S3 as 2, it's very clear. A5 as 3 and S6 as 4. Yes, a repetition has been done here only to cement the idea in your minds of what is a basic variable and what is a non-basic variable. Now what we do is we look for the non-basic variables and find where do we have the highest negative sign. Now the highest negative sign is for x2. So we draw a box in this column. And then afterwards, what we do is we take, leaving the first equation, that is leaving the Z equation. We take all the other rows and in all the other rows, we take the RHS and divide it by the coefficient under x2. And see where do we get the least ratio. Now the least ratio, of course, is for A5. 3 by 3 is 1. So this is the least ratio. So we make a box, or we draw a box in this entire row. Now what we do is we do row operations in such a way so that we eliminate the value. Okay, so that we make the value of all the coefficients under x2 as 0. Okay, so this means if the first equation is taken here and I have to make 299 as 0, it's going to be R1, that is row 1, plus 299 divided by 3 into row 3, right? So this is row 1, row 2, row 3, and of course this is row 4. So again I repeat, row 1 plus 299 divided by 3 multiplied by row 3. So this is going to make all the coefficients in the column of x2 as 0. So let's see how do we do these operations quickly with a calculator. Okay, I have my on-screen calculator now. Now let's get ahead with the calculations. So the first operation is going to be row 1 plus 299 divided by 3 into row 3. Okay, so let's get ahead and do it. So for this we have to do alpha A plus 299 divided by 3 alpha B. And don't forget, press calc. If you press is equal to, all mistakes will happen and you won't be able to track it. So you have to be very careful to see that after you do this, you press calc. Okay. So now the first entry minus 299, that is just to check. And B is of course 3. Are we getting 0? It's fine. So let's start with our calculations now. Once again, press is equal to minus 103 and B is 1. So we have 10 by 3. So that's minus 10 by 3. I have written it down here. The second entry, of course, is 0. The third entry, because it is 0 and 0, it's 0. Why waste time on calculator when we can do it mentally quickly? Okay. And the fourth calculation, of course, let's do it. So that's going to be 100 is equal to and minus 1. Minus 1. So that's going to be 1 by 3. And this is followed by 0 and 1. So let's do it. Press is equal to once again to get A. That's very important. Okay. So that's 0 and that's 1. So you get 299 divided by 3. 0 and 0 of course is 0. And then the last one, that is once again is equal to minus 300 and 3. So we get minus 1. Similarly, I have done all the calculations. I'll demonstrate it for S6. So I press is equal to and then I press AC to remove the previous equation. Now to eliminate the 1 in S6 and make it 0, it's going to be A minus 1 by 3 B. So that's going to be alpha A minus 1 divided by 3 alpha B and calc. This is very important. Now press calc. There we are. Once we have pressed calc, now we can get ahead with the calculation. So let's check our calculation for x2 first. So A is going to be 1 and B of course is 3. Let's check we are getting 0. Yeah, we are done. We are pretty much done. So 0 minus 0 is going to be 0. Then 0 and 1 is going to be nothing but 0 and 1 is going to be minus 1 by 3. There we have it. And this of course is going to be 0. 0 and 0 is 0. 0 and minus 1 is going to be 1 by 3. And 0 and 1 is of course going to be minus 1 by 3 because it was a minus 1 by 3b. And of course 1 and 0 is going to remain 1. And let's do it for the last one, that is press is equal to once again 3 and 1. So we have it here. Okay. So I think there is a mistake here. I did a mistaken calculation here. Let me do it once again. Is equal to a. Yeah. A is 4. Yes. And it is 3. There we go. So we have got it 3. By mistake, I had entered a as 3. Okay. So we have 3 here. So we are pretty much done. X2, similarly, it is done. Okay. So X2, you don't have to do any calculation, obviously, because it is the row which is being subtracted from the other rows or added from the other rows to make others 0. So it's going to remain as it is, but I have divided it by 3. Now, S3 is the calculation that you need to do it and check it for yourself, right? Now, let's get ahead. Okay. So I have taken the previous result, that is the previous iteration, and written it on the top of the slide. Now the entering basic variable obviously is x1. The reason has already been explained to you, but just to repeat it, the minus entry, the highest negative entry is taken, and that is taken as the entering basic variable. So to find the leaving basic variable, you have to do nothing but take the RHS and divide it by the coefficient under the entering basic variable. So that's 1 divided by 3 by 5. That makes it 1 divided by 5 by 3, my bad, that makes it 3 by 5. So 1 divided by 1 by 3, that makes it 3. So this is the least ratio. And of course, you do not have to consider the negative entries. Okay. If you get a negative ratio here, you don't have to consider that. So entering is x1 and leaving is s3, right? So now let's get ahead and do with the calculations. So AC here. So this is going to be nothing but 10 by 3 and 5 by 3. So to eliminate this, all you have to do is multiply it with 2. So that's going to be alpha A plus 2 alpha B. That is for the eliminations in the first row. So press calc, and that's going to be minus 10 by 3 and 5 by 3. So you have 0 here. Now the next one is obviously again going to be 0. The third one obviously is going to be nothing but 2. The fourth one obviously, let's check it up. So let's press is equal to, so that's 1 divided by 3, and that's B is also 1 divided by 3. So we get 1 here, 1, and similarly we get 99, 0 and 1. I have done all the calculations in the similar fashion, but let me demonstrate that for x2. So for x2, it's going to be nothing but 1 by 3, and this is 5 by 3. So it's going to be A minus 1 by 5 B. So let's do that. Alpha A minus 1 divided by 5 alpha B, and press calc, right? So now let's check it. So for checking, we have to first enter A is 1/3. So that's 0.33. That's okay. And this is 5 by 3. B is 5 by 3. So 5 divided by 3. And you get 0 here. Okay. So of course, 1 minus 0, that makes it 1 here. And therefore, this is 1 and this is 0 and this is 1. So this makes it minus 1 by 5, which is obvious from this equation. And then minus 1 by 3 and 1 by 3. So that's a bit tricky. So let's do it. So it's going to be minus 1 by 3. That is minus 1 divided by 3. And 1 divided by 3 is B. Okay. So I seem to have made a mistake here. So let's do it once again. Minus 1 by 3 and 1 by 3, yes, and press is equal to, that's minus 2 by 5. And there you can see the entry here, it's minus 2 by 5 is written. Similarly, you get 2 by 5 here because it is the exact opposite now, the calculation. So 2 by 5, here you get 4 by 5, here you get 16 by 5. And with the second iteration, you are done with the solution. Why? Now, because you do not have any negative numbers in the first row. Okay, so we are done with the solution. Now we need to find out what the solution is. Okay, so just pay attention here now. The basic variables are now x1, x2, and s6. And the non-basic variables now will be a5, s4, and s3. Okay, so these are now going to be 0. Right? Now, what is x1? x1, if you go to see, the coefficient of x1 is 5 by 3. Okay, the rest everything is 0 as explained to you, because it's 0 under s6, but the other ones are 0. So it's going to be 5 by 3 x1 is equal to 1. So x is equal to 3 by 5. A similar logic goes in explaining the value of x2, which is going to be 4 by 5. A similar logic goes in finding the value of s6. Right? So s6, the coefficient is 1. So that's 16 by 5. So having noted that x1 is nothing but 3 by 5, x2 is nothing but 4 by 5. If we put it in z, we get 1. Right? Now, if we put it in the first constraint, we are bound to get 2x1 plus x2 as 2. In the second constraint, it is going to be 3. And in the third constraint, if you go to see, x2 plus s6 is 4. So if you take 4 here and you take the value of x2 here, so that makes it 4 minus 4 by 5 makes it nothing but 16 by 5. Right? That is 5 fours are 20 minus 4 makes it 16 by 5. Right? So we are pretty much done now with all our calculations. So that was the end of it. As you can see here, using the calculator powerfully and taking the value of m makes the calculation much more simpler and error free. If you like this video, forward it to others. Do like and subscribe and do comment. In your comments, write down if you would like to have a lecture made on any other topic of operation research. Goodbye, friends.